Hello, question number 59. It reads, on top of a cylinder with a horizontal axis, a plank is placed, whose length is L and thickness is H, for which radius R of the cylinder, the horizontal portion of the plank is stable. So this is a sphere, capital R radii, and this plank has been placed on this. So this is located here. Now we need to check for the condition for which this plank is going to be stable. So whenever we need to check the stability of a system, what we need to do, we need to disturb the system a bit and then consider the forces and torques acting on it, or maybe in terms of energy. And if we are going in terms of forces or torques, we need to find that the forces or torque are restoring in nature. If it is so, then it is stable. Otherwise, you can claim unstable. In terms of energy, if we go, then we say that if energy is increasing, so unstable, and energy is decreasing, so stable. So let's do in terms of force and torque. Now for solution, I have made this picture, so we will consider this picture after this picture. This plank has been slightly rotated towards right. So initially, let's say this point A. Let's name this point as A point. This A point was on the sphere surface. Now the B point has come to the sphere surface. Let's say this reference point, center point is O, and the center of the plank is, let's say, denoted by C symbol. So A, B, C, these are the points. A was initially in contact with the sphere, and then B is as in this particular condition, and C is the center. Now let's consider this thing. Let me elongate or extend this line passing through O and initially. Now if we consider about point B, now with respect to point B, if the resultant torque is in this manner, that means anti-clockwise sense, then you'll find this plank is stable. If the resultant force is towards clockwise on the plank we're talking about, so we will say the plank is unstable. But if we look the free body diagram of this plank, we will find the gravitational force of this will act on this plank, and that will be acting at point C. Okay. Now, if that gravitational force, let me draw that here. If that gravitational force is lying on the left side of point B, then this force is going to create anti-clockwise torque, which will indicate the stable condition. However, if this force goes on the right side of B, that means C point is maybe like certain height this, so that it is located in this way, then you will be finding the torque of gravity will be clockwise, and it will create instability. In this picture, I have shown this thickness is very small, so C is looking like this, and our desire is to create a stability, so we will say this gravity must be acting at C like this. So we can say that if we consider this line where the gravitational force is going to go through, and if we consider another line which is passing through B, these are parallel lines, vertical lines, and if we consider two distance, let's say this one, this is x1, and this distance from here to here, this entire distance as x2, and we can claim that if x2 is greater than x1, then plank is stable. So stability can be checked of the plank if by measuring this x1 and x2, right? Now how to measure this x1 and x2? For that sake, we can draw some picture, maybe like this. There is this line O that is passing through O, and there is a point B somewhere here, and there is a point A, and there is a point C somewhere there. So I'm redrawing another picture. So this point is indicating A, this point is indicating B, this point is indicating C, and let's say this angle is alpha, so this is also going to be alpha. Why? because you'll find this AB is going to be perpendicular here, and this is also going to be perpendicular there. So these two lines are going to be parallel. So we can think of these two angles are identical. Now we can have a perpendicular, maybe like this, from C to this line and from B to this line. We are calling this above one is as x1 and this below one is x2. Now we can easily compare these x1 and x2, right? Now this distance is definitely the radius, so that is r, and therefore x2 can be written as this is going to be 90, of course, right? We are putting the perpendicular, so x2 will be r sine alpha. Similarly, this AC distance is known to us, that is the height of the center, so that is going to be h by 2. Therefore x1 is going to be equal to h by 2 sine alpha. Now for stability we need to do this x2 greater than x1. So since x2 is to be claimed as greater than x1, which will ultimately say that r sine alpha should be greater than h by 2 sine alpha. Now alpha is non-zero number, so we can cancel out sine alpha from both sides. This indicates the condition for stable equilibrium or stability is r is greater than h by 2. Now we know the relation between h and r should be like this in order to get the or claim the stability. That means if r is less than h by 2, that means h by 2 is going to be higher, and then the gravitational force shift toward the right of the B, and then the plank will want to be stable. In this particular situation, gravitational force will pass through the C, and B point is going to be the right side, so the resultant torque about B is going to be in anticlockwise sense, and the plank will remain stable. So this was the condition that we are supposed to find in this particular question. Thank you.